Greetings, everyone, and welcome to another episode of The Launch Space. Thank you very much for joining us. We got a great show today. My name is Brian Benz. I'm a cloud advocate at Microsoft, and I'm joined by a few folks. We're going to talk about Dapper today. But before we get started, I do want to mention that this is a live show. You can ask questions and share any feedback you have at aka.ms/learntv. So let's get started. We've got three great folks here today. Mark, I want to start with you if you just want to give us a brief introduction.
Yeah, hi, my name is Mark Fussell, and I'm a program manager that works in the Azure Incubations team.
Awesome. Donovan?
My name is Donovan Brown. I'm a teammate of Mark Fussell, so I work on the same incubations team.
Great. And Nitya?
Hi, my name is Nitya Narasimhan. I'm a senior cloud advocate in the developer relations team, and I'm here because I like sketchnoting, and we've got a visual guide to Dapper.
We do have something very special today. So we have Mark's going to do a introduction to Dapper and how we can overcome some of the challenges you have with microservices. After that, Donovan's got an awesome demo that he's put together using Twitter and managing sentiment using some AI tools that we have on Azure. And Nitya is going to be sketchnoting her impressions of the whole thing while we go. And at the end of the show, we're going to come back and review everything, as we always do, but this time with an added bonus of some visuals from Nitya's sketch notes. So we'll start with Mark. So Mark, if you want to take it away, we'll get started with intro. Thanks.
Hi, fantastic, Brian. Thank you. It's great to be on your show, and I'm pretty excited to talk to you today about Dapper. So I thought I'd just kick a few things off about, we hear a lot about microservices development. I'm not going to go into what microservice development is too much because, there's a whole topic in itself on that. But suffice to say that, if you're building a service today, microservices architecture is the way that developers are taking their direction. And the problem is we've been asked to get developers to build these microservices applications, and really we haven't given them the tools for the job. The tools to build these distributed applications are hard. Developers end up building it themselves. There's limited tools and runtimes to build it. That all takes away from you from building your actual true business application and getting the value behind all of that. And so too much of that work is placed upon developers. Of the frameworks that are out there, we find that they tend to be limited. You sort of have to wait for that runtime to add a certain set of features. And also sometimes you have to go all in with that particular runtime and adopt it in its entirety. And you can't just say, wait, look, I've got some code already. I just need to move this and make this a microservice and migrate my existing code. So, it's a lot of a throwaway and migrate. And then also we find that sometimes, particular runtimes say that I'll only work on this particular cloud provider. They'll only work on the edge, or they'll only work on a particular hosting platform like Kubernetes. And so you need this portability. You need to be able to have multi-cloud. You need to have portability across cloud and edge. You need to be able to host anywhere. So these are sort of the problems in sort of the Microsoft development space. And so that's why we thought about these problems. We took all our experience that we've been building in Azure for years and years and years, and also with all our customers, and we came up with Dapper. And what Dapper's goals are is that it wants to give you sort of these best practice building blocks. We took all that experience and we codified it into these building blocks. Importantly, you can access this from any language or any framework of your choice. So you're a Go developer, or a C# developer, or a Python developer, you can use Dapper. We did everything around these sort of consistent APIs that you can call over HTTP or gRPC, adopting standards wherever we can, like tracing standards and how we do logging. Importantly, we made it very pluggable so that you can plug in all sorts of different components. You'll see what this is in action when we talk about this. So if I want to store all my data inside a Redis database and then I change my mind and I want to move it to something else like Cosmos, that's all very pluggable. Make sure that it can run on cloud and edge and all your platforms. And most importantly of all, the whole thing is community driven and vendor neutral. It's built by the community, built for the community. In fact, we want you to join us as much as we possibly can, helping us get Dapper off the ground. And in fact, to date, we've had over 800 contributors to Dapper in the last year and a half since it's been released. And so there's been a huge growth of people, and we just love that side of things. So let's get into what Dapper is a little bit, and then I'll give you a little demo. But at its essence, Dapper is these set of building blocks that make you like a superpowered developer. And there are things like, how do I call between two services? It's a very common problem I have to do inside of Microsoft space. I've got one app service here. I want to call another one. I have to discover where that service is. I have to do retries. I want to do it securely. All of that. It's actually sort of a hard piece of code to get done. I want to store some state inside there. I want to make this a long-running, stateful, resilient service. How do I do that? Most microservices have a sort of an event-driven architecture, whether the events are coming from outside, from some like a Twitter feed or from some other queue, or you just need to do publish and subscribe between your events. So you have to sort of event-driven architecture around these things. So these are the building blocks that Dapper provides you: secrets management, observability, diagnostics. You can access them over your favorite HTTP or gRPC framework. And so that's exactly what happens. Dapper layers on top of this. You come in it with your the programming language of your choice, and just start to use it. It's as simple as that. If you can do HTTP, you can use Dapper. The key thing is, though, is like, where does all this functionality rely? And what we've seen with a lot of these architectures that emerge is that you take all of this great functionality and you start to load it as a thing called a sidecar. That's a thing that sits next to your application that you can call over a local call, a networking call, in order to provide all this functionality. So you don't have to embed this all in your code. You just do a local HTTP call around that. Now, Dapper itself will actually host on top of any platform. So you can actually, you can not only tie this to Azure, but if you want to take all your code and move it to another cloud provider, you can. But it'll also run on top of things like Kubernetes, a set of physical machines, VMs. It's host independent around all of these. But returning back to that sidecar model, here's what it looks like. Here's your app. Here's Dapper. And so you simply do your HTTP call or gRPC, and Dapper does all the heavy lifting for your app. And this is key. So, and the key thing here is that you get these standard sort of API calls that I can use. So here's an example. If I want to call this new order method on the cart application that's somewhere in my environment, I don't know where this thing is, Dapper will go off and discover where it is, marshal a call to it all, call a new order method, do that securely. If your application fails, it'll rediscover where the new instance of the card is running, reconnect it again, and does all that hard work for you. So you as a developer, you'd simply go localhost, and here's the API I call. Dapper takes care of all the hard work for you. You can do things like save state, or you can do publish messages, and you can get hold of secrets, a very, very common thing to do. So say you wanted to get hold of that secret to access your database. Now you'd have to go in and effectively include your favorite SDK for the secret store you're going to use, say Key Vault. You have to put that all in your code. You have to make sure it all works. Well, instead, you can just say Dapper does all that heavy lifting for me. I can just use the secrets API to go off to Key Vault to get hold of the passwords, and Dapper takes care of that for you. So these are some of the scenarios that we find that are just really compelling to get you as a developer to be more productive and effectively start to kind of focus on the business logic, not building hard platform code like this. Dapper effectively makes microservices super, super easy for you, and that's his goal. If you look at this just a little bit bigger and expand it out a bit, you'll see that you can actually have two applications that run, and each one of them launches, and they have their own Dapper sidecar. As I showed in the last one, using those APIs, you can get hold of different types of state stores through these different components down here. So I can plug in DynamoDB or Cosmos or Redis or Cassandra. There's many of these built and donated by the community. I can do triggers from external systems as well. So if I want to trigger from like an event hub to trigger my code. And then here you can see that Dapper talks to other Dapper instances running in my environment, whether that's on my local machine or it's on Kubernetes, which you typically sort of use in production, or a set of physical machines. Dapper here now, if I want to do that service invocation call, Dapper will take care of doing all the hard work of discovering where, if I want to call from service A to service B, it'll find it all for me. So this kind of gives you this sort of overview of what Dapper is, the problems it solves, and really how it does all the heavy lifting for you so that you can focus on what's inside your applications here, inside your services, your microservices you're building, and let Dapper take care of all of the hard, difficult distributed systems problems. Okay, let me go off and show you a demo then, because I think demos are a great way to kind of get going inside here. Here, let me just pull up Visual Studio. I've got a blank directory here, And what we're going to do here is we're going to create a new .NET application. So I'm going to go in here. I'm going to do new .NET web app. We're going to call it. We're going to create a web app inside here. I'm going to do this as a web API. I'm going to give it a name. I'm going to say name. We're going to call this Dapper app. And I'm just going to do, just don't have any HTTPS on this. Going to do no HTTPS inside here. So I'm going to create a brand new .NET. Actually, so I got this wrong way around. I got .NET new here. So .NET new web API. And let's run this and create a new .NET application. So what does this do? This creates a directory for me. If I just cd into this directory inside here, I can now do .NET run. And just as you expect, I'm going to run and build this .NET application. It's a web application. I'm sure you've done this before yourself. Once this thing gets built, you see it creates me a URL inside here. If I just open up this URL and go into my browser, you'll see that I can actually call on to the weather endpoint on this weather forecast. And so if I zoom this in a little bit here, you'll see that I can just generate new weather forecast summaries. This is just sort of a standard new .NET application. Great. So we haven't done anything kind of crazy just yet, but what we're going to do is we're going to take this application and we're going to turn this into a Dapperized application. Now, what that means now, I've got this application. I'm going to solve all those hard problems for myself. So, if this was an application myself and I was trying to build it as a microservice, I would have to think about, give it a name so I could discover it all. I'd have to be able to figure out how do I talk to it securely? How do I turn on diagnostics? Well, Dapper takes care of all this for me. So what I'm going to do is I'm just going to now go back here and now I'm going to Dapperize this application. Now, Dapper itself actually has a CLI. So let me just clear the screen here. If I just do Dapper here, I've installed Dapper on my machine. It's pretty easy to install. You just download a CLI SDK here. This is the CLI. You'll see that there's a number of things here of commands I can do. And to get up and running, you can just use Dapper init. So they're very simple. Once you've got your Dapper installed, your CLI, you can do Dapper init, run this, it installs Dapper on your machine, and you are ready to go. So now I've got a whole bunch of other commands inside here. I've got one here called Dapper run. What does Dapper run do? It takes your application and it launches your application and that Dapper sidecar together. So you've Dapperized your application. So let's go off and Dapperize this application that we did before. So we had .NET run here. So we're just going to go Dapper run. And we're going to give this a new name. This is the great thing about Dapper here. So I'm going to say app ID here, and I'm going to call this a Dapper. Let's call this Dapper app, like this. So that's a unique name, and now I have to reference my microservice. So wherever it runs in my environment, Dapper can find it for you. Think about what you have to do for that normally. You have to figure out DNS tables, figure out how to route to them all. If it failed over, you have to restart them all again. This just discovers that for you. I have to tell Dapper what port I'm going to talk to it on. So I'm going to talk to Dapper itself over HTTP here. I'm choosing HTTP, and I'm going to choose an HTTP port, and I'm going to choose 3500 for it. And then I just have to tell Dapper, because it talks back to my application, that with this application we created was on port 5000. So there it is. I've Dapperized my application. Let's run this. So this now has got up and running. Same thing as I had before. Same application I had running before. If I go back here to my weather forecast and I refresh this, you'll see that same thing is running before. There's no difference. That same URL works. But let me just split my terminal here a moment, because I want to show you what I can use with the Dapper CLI. I can do Dapper list inside this here, and you'll see now that I have a Dapper application running here. So here it is. Here's my Dapper app that's running, listening on 3500. So instead, I can actually use Dapper to invoke my application instead. So let's just go back to the browser here. And if I now go and call that Dapper API, I can do a local host call here. I can do 3500. Let me just zoom in here so you can actually see this here. And you can see that I can say, I'm going to use the invoke API to call the weather forecast instead. I do have to just change this here because I had this was actually Dapper app inside here. So this is Dapper app, that's what we called it. And now when I run this, boom, I get the same set of responses I had before, but this time I've done it through the Dapper URL inside here, getting all the great benefits of Dapper. like diagnostics, discoverability, failover, security, and all these things. So let's take this a little bit further, because now if I just hit this URL a few times, let me show you some of the things I can do. Because I've got Dapper running as inside this, I can actually go and look at the diagnostics for all this. So you see when I set up my local environment down here, we actually set up, I do Docker ps here. One of the things we set up in the environment, we put Zipkin on your machine, and the Zipkin will gather all the diagnostics for you and see what's happening inside your application. Now, what I can do here is actually I can take this application here and I can go and look at those diagnostics. So let me just go in here and open up the Zipkin on the local port here. And so here I have now, I've done a launch Zipkin. Because Dapper logs all the calls for me on my behalf, not only within my application, but through the whole application map. So if one service calls another service, I can see that whole call graph. So let's run this query here a moment. Let me just zoom this down here. So you can see here's all these diagnostics calls. If we just take one of these, here's that weather forecasting call that I just did. I called on to, did this get call on to invoke Dapper web app method inside here. And I can see all the information about my local call to this. Now, this says I just did one call on my one local machine. You can see the call trace between all of these. But this I got out of the box for free. And that's sort of the crazy easy thing about Dapper. It gives you all of these capabilities around there. So that's kind of Dapper in a nutshell as you take it off yourself. And all I did was I called this over HTTP and showed how simple it was. Although we recognize that actually, what you wanted to do sometimes is that some developers wanted a more in-depth experience for the type of language that they had. So what we also did is that we actually, let me just open up a new, let me just minimize this PowerShell here a moment. What we also did is that we also made sure that there was a first-class experience for every one of the developers who came at it from SDK. So in this particular case here, I just created a new .NET application here again. There's a program.cs file here. This is just a console application. And you can see that I just included Dapper client. That means that I can put in a Dapper client if I want to. I'm happy to use HTTP, but if I want a kind of a richer experience with some IntelliSense, I can put in this Dapper client instead. And if I look at this Dapper client here now, I can write a very simple application like this one here. I just have a main here. I can take advantage of this Dapper client builder here. And now I can take advantage of all of the great calls inside here for getting hold of things like getting hold of invocating another service. I can get hold of secrets. I can store state, which makes for a long-running service. And so I can take advantage of Dapper through an API mechanism. What I've gone and done here is I've used another of Dapper's capabilities to save some state inside my application. So here we have this and why do I want this? Because it's very common for you to have a shopping cart or the session state for your application or a workflow. This is how you make long-running stateful microservices. So here I've used client get state. I read it onto the state store. Dapper has this concept of components where this state store can be a component that I talk to. In this particular case, I made the component a Redis host, which means that I'm storing all my state. You see here, it's got state store into a local Redis host that's running on my machine. That's something that we also just set up for you in your local development environment when you did that Dapper in it. So let's go off and run this application like we just did before. Let's open up a new terminal. Just as we did before, I can do Dapper run. I can give this a name. I can call it app ID. I call it Dapper counter. And then I just do, like I did before, .NET run. And now I'm going to take this application and I'm Dapperizing this one and I'm running this. So here I'm using the SDK now. It up comes and running. All this thing does is it stores counters inside my local Redis cluster inside here. And you'll see that these counters are running. And the good thing about this is if I stop this application and kill it, and then I run it again, it's a stateful application. It'll come back, it'll pick up the counter value, and it'll kick it off from where it was before again. Here's 9, and keep going like this. Can I see this data? Yes, of course you can. You can go off this local Redis viewer inside here. if I just refresh this, and I see inside here, this is my Dapper counter. And you see inside here, if I refresh this is my Dapper counter inside here, looking at this in my local Redis state store. The beauty is that if I wanted to use exactly the same code, but plug it in for something else instead, all I have to do is switch out my code here. Instead of pointing to state store being a YAML component in this particular, a Redis component in this case, I can replace this for any other state store of my choice, and I don't have to change any of my code. So that's kind of like a great intro to how you can use Dapper from its component side of things, all the power it gives you for those microservices, and at the same time that you can take advantage of using HTTP if you want, or you can go into this SDK world of the view. That's what I had, Brian. Back to you.
Thank you. That was great. It's always great to see how you can actually make things a lot easier by just wrapping them around a whole bunch of work that other people have done. Take an application that didn't have state, didn't have security, and just add those things and put it on the cloud. It's pretty awesome. Hey, we did have one question. Real quick, we've got about a minute. What's the best way to install Dapper? Get started.
Oh, okay. Yeah, let's do it together now. So the best thing to do is you go off to, let's go to Dapper.io. So if you go to Dapper.io here, this is the web page that gives you a little bit of overview, and you just go and click this button here saying, try Dapper. And it'll take you to our docs page. So you'll see up inside here, you can go straight there. You can go to docs.dapper.io, getting started. If you want to install it inside here, the first thing you do is you install the CLI. And so all you have to do, whether you've got Linux, Windows, Mac, if you've got a Windows machine like I have, just copy this PowerShell command here, open up a PowerShell window, run it. Once that's completed, it gives you the CLI I just showed you. So this will give you the CLI inside here. So now I'll just have Dapper CLI like this. So this will give me my CLI. This is a Windows. Once you've done that, if you just follow the next step inside this tutorial and you go to the next step inside here, the next step basically says is do Dapper init like this. So if you run Dapper init on your machine, Dapper init like this, that sets it all up. And then you can sort of check the version that you've got. In my particular case, the version I've got is Dapper 1.0, which is the one that we released to production last month. This is the great thing about Dapper. We've been working on it now for about 1.5 years publicly. When we released the 1.0, this proved that we actually had customers running in production with Dapper today. So yeah, so go back to this tutorial, keep going through this tutorial. It'll give you a little go with sort of the Dapper API. And then when you end up in these sort of quick starts along here, there are these Dapper quick starts here, and walk through these quick starts like this Hello World one and this Hello Kubernetes. And then you can explore from there.
Awesome. Great. Thank you. Wonderful. Well, thank you, Mark. That was a great overview. And now we're going to dive into a demo with Donovan Brown. He's got something that he's worked on just to get to know Dapper. And it's a pretty awesome setup, actually. Donovan, I'll let you tell them a little bit more about it. I'm going to be behind the scenes tweeting. So, Donovan, whenever you're ready, let me know, and I'll start the tweets that manage the demo for us.
Perfect. Cool. So yeah, so I'm new to the incubations team, and Dapper is obviously a project that we were working on when I joined. So I wanted to learn as much as I could about what Dapper is and how it makes my life as a developer easier. And what we came up with is this really cool demo that strings together 3 different microservices and several different components. And as a developer, when you look at a map like this, you realize that, wow, okay, we're going to have Twitter involved. So now as a developer, I have to figure out, how do I communicate with Twitter? What does that API look like? What SDKs for Twitter do I have to download? We're going to store state, and storing state could be inside of Redis. It could be inside of Cosmos DB. It could be in MySQL. So do I then have to add all those components and all those SDKs to my project as well? And then I have to have PubSub so I can move the data between my different microservices. And every time I see a different interaction, I'm thinking, wow, it's a whole other set of APIs I have to learn, another set of SDKs that I have to install. But then they introduced me to Dapper and said, no, Donovan, Dapper does that. You don't have to do any of that stuff yourself. So in this application, what happens is someone's going to send a tweet, and Brian and Nitya and anyone else who wants to, if you put Dapper does that in your tweet, all as one word, I will start to see that tweet. And I don't have to write any Twitter specific code. Every time a tweet that matches my criteria is sent, this binding will automatically call a post method on my microservice. So all I wrote was a post method, which all of us know how to write. If you've ever written an API, you can already write this and start taking input directly from any binding. We're using Twitter as our binding here, but you can have bindings for all sorts of different components. When the tweet comes in, the Twitter binding fires, it calls my code. And then I use Dapper to call another microservice. Now, this is where you're doing service-to-service invocation. And as Mark mentioned earlier, you'd have to know the DNS records. You'd have to worry about recycling those. You have to know how many instances there are and load balance that. You have to worry about retries. If I try to make a call and it doesn't work, how do I handle my retry logic? How do I do circuit breakers? There's a lot of logic when it says I want microservice A to talk to microservice B. There's a lot of stuff that you normally have to deal with. But in my case, I just say, hey, Dapper, I need you to go call this method on this other microservice. When you're done, let me know. And I don't have to worry about the retries, the back off logic, the circuit breakers, the service invocation, the service discovery. I don't worry about any of that. Say, hey, Dapper, go call this. And when you're done, give me my information back. That's exactly what happens. I take the tweet, I send it over to this other microservice, who then communicates with cognitive services up in Azure and says, hey, here's the text to this particular tweet. Go tell me if that's neutral, if it's positive, or if it's negative. And then when you give me that information back, I'll share it back with the first microservice. I then take that information and I store it into a state store. I'm going to show you how I do this locally on my dev machine, and then how I'm able to take all this code and package it and move it into Kubernetes without changing a single line of my application. But I'm going to change the two components here at the bottom. Once I have my state stored, I then use PubSub, where I'm able to publish events and then have another microservice subscribe to those events and pull them off of the queue. So I publish an event saying, hey, I've scored this particular tweet, put it on my PubSub, and then I have a viewer microservice that says, okay, I'm going to subscribe to those tweets coming off of the PubSub, and every time I see a new one, I'm going to display that to the user for them to see. So we have 3 microservices and 3 components, and we're still doing service-to-service invocation. That would give me a heart attack. I really drug my feet when it came to getting involved inside of microservices, because I thought I don't want to deal with all the complexity of running a microservice. Writing one is kind of easy, but making it work in this ecosystem was very, very hard until I realized that Dapper does that. It does all the heavy lifting for me. So let me start showing you some of the code that I'm talking about. As Mark showed you earlier, you can use an API if you like. If you're into SDKs and you're using a language like .NET and you prefer an SDK, you can do that. This is a Node.js application. And to use Dapper, all I did is define these endpoints. These are simple HTTP endpoints to localhost and whatever port Dapper happens to be running on. I don't care about anything else in my ecosystem. I just care about Dapper, because Dapper is going to take care of everything else. So when I want to save the state, I simply go to the state store called Tweet Store, and I say, hey, I want you to store this information for me in whatever state store I happen to be using. Could be Redis, could be Cosmos, could be MySQL, could be anything. My code doesn't change. I do the exact same thing. I get the desired result. Here I have a PubSub. I'm going to publish these events to these topics to this particular subscription here, and I want them to be picked up on the other end. Again, it's just a simple URL that I post to. What's beautiful about using these URLs is any language can do this. Languages that don't even exist yet can use Dapper the moment that they're released, regardless if there's an SDK or not, because with an HTTP or gRPC call, you can use all the power that Dapper has available to you. And just here, I also have this sentiment analysis. This is where I'm making that service-to-service invocation. I don't know where it is. I don't know what language it's written in. I don't know how many instances of it there are, but I know that it exists, and I want you to go call it for me and do the hard work. This is the post that I wrote. I wrote this one method, and then the Twitter binding says, hey, every time I get a tweet, I'm going to post that tweet for you to this particular endpoint. Great. So I write a post, I give it the right route, and all of a sudden the tweets just come pouring inside of my particular piece of code. First thing I do is I go and I score the sentiment. After I get the results of the score, I save the content into a state store, and then I publish it to a PubSub. And I just basically wrote some little convenience methods down here for me that do that exact same thing for me. So that's all we're doing in this particular code. So the code that you have to write is really, really simple, and it's just plain generic code. Now, how do I configure those components that we've been talking about? All they are YAML files. I have one of them that says, hey, I want to use a Twitter binding. And then I give it the credentials that you'll get. So you'll go into your Twitter account, you'll create the necessary credentials, you fill in the blanks here, and you give it a query. And my query says, Dapper does that. So any tweet that contains that text will be sent to my endpoint, and then I can process that particular endpoint. Here I said I want to be able to store state, and that state that I want to be able to store is going to be backed by Redis. And all I have to do if I want to switch from Redis to Cosmos DB or to MySQL is simply change the type of this particular component, and I'll be able to save state without changing a single line of my code. I cannot tell you how cool it is to be able to say that my code does not change regardless of the components that I'm actually using. If I'm running on-prem or in the cloud, in Kubernetes, in the cloud, or on the edge, none of my code changes. It all stays the same. I just reconfigure my components. And then here for PubSub, I did the exact same thing. We happen to be using Redis for both PubSub and for state, but I could actually mix and match those, which I will do once we move to the cloud. And if we start running this particular application, what it'll look like is we're going to have an app that looks like this. And every tweet that's been sent so far, since this is a live show that has the word Dapper does that in there, has started to show up here automatically. One of the things that Mark talked about is the fact that we get observability and logging for free. Like, it just starts working for us. And what's really cool is that I can actually track every single one of these tweets from the moment it enters our application to every microservice inside of our application, all the way to where it's being shown to the individual user. I'm doing that using Zipkin. Again, this comes right out of the box. And now if I expand this, you're going to be able to see that this is the path that a single tweet took through our microservices architecture. If I expand this even further, we can see that the Twitter binding came into our app, entering inside of our provider microservice. Our provider microservice then took that information and it scored it using the sentiment analysis microservice. This is where we made that service-to-service invocation call to the other microservice. And here is the other microservice you were using, which is the processor. When that information came back, you can see that we then stored the results of the scoring into our state store. After we stored it into our state store, we then published that same tweet to our PubSub. And then from our PubSub, it was read by our viewer. So here is me tracking how long it takes a tweet to enter our system before it's actually being shown to our end users. And at any point, should there be a latency or something that's really slow, I can now diagnose where my bottlenecks are using the logging that comes right out of the box, which is just fantastic. Now, when I'm running this locally on my machine, one of the things that's really cool as well is that if I bring up my window here, I can show you this window here, that these are the logs that are happening in real time. So this is one of the things that makes developing on Dapper really nice when I'm running locally. Spinning up multiple instances of my microservice is really easy, and all the logs for everything that's happening. One of these panes on the left-hand side is my processor microservice. The pane in the middle is my viewer microservice. And then the pane on the far right is the microservice that's getting all the tweets called my provider microservice, and you can see it scrolling. So all this information is real-time logs so that when I'm debugging my application locally, I get all the rich logs that I need. I don't have to go digging into config files or log files or trying to get up event viewer or some other odd tool to figure out what's happening in my application. All the logs are happening for me right here in front of me. So I just simply ran Dapper run, just like Mark showed you, against all three of my microservices, and all of a sudden Dapper was able to start to see across all those different microservices and get everything to work the way that I wanted it to. Now that I see the application working locally the way that I want, now I want to move it to the cloud. But when I move it to the cloud, I'm not going to use Redis as my backend. I want to use some of the cloud-based products that we have instead. So if I were to come over here and look at the two things that I changed, the two files that you're looking at right now are the only two files that I had to change to take my application from my dev machine and move it inside of Azure. I simply said, I want to start using Azure table storage for my state store instead of Redis. And I want to start using Azure Service Bus for my PubSub instead of using Redis. Now I'm going to start taking the power of the cloud that I choose to use. And these components can also be for third-party clouds. It could be for components that you have on-prem. But all I changed was this and not a single line of my code. And what I do is I now have that exact same application running in the cloud. This is a cloud version. As you can see up here, this IP address is to a Kubernetes cluster that is running this particular application, the same one you saw running locally before. I get the same Zipkin, but instead of running against localhost, again, this is running against the cloud, and you're getting the exact same type of tracing that we got before, even though this cloud code is now running inside of Kubernetes instead of running inside of my development machine. To show you what this looks like in the cloud even further, if you come over here, this is the resource group that I spun up that hosts all the information that we need to host this in the cloud. Here I have the Kubernetes cluster, which is where all the pods are actually running. And I'm going to show you a pod and the Dapper sidecar right next to it. Here we have cognitive services. This is where we're sending that text of the tweet to so that it gets graded for us and scored and then brought back down to our processor microservice. And then here is our service bus. This is where we've actually created the topics that we need to be able to post events to so that I can have my pub sub handled inside of Azure. And then finally, my storage account, which is where I'm storing all those tweets after they've been scored for future processing. If I were to go ahead and drill into my Kubernetes cluster, I can start drilling into my workloads. One of those workloads is my processor. And alongside the image that I've produced for my processor is the Dapper sidecar. And this is where all the magic happens. When you're talking about security between communications, service invocations, secrets management, state management, bindings, input and output bindings, and observability, when Dapper does that, it does it in that particular sidecar. It's a very tiny sidecar. It only adds about a millisecond to any of the transactions that you're dealing with, so it's almost insurmountable. You don't even notice that it's happening, and it's only about 4 megabytes worth of space when it's actually running next to your app. For all that you get, it's free, right? When you look at the latency that you might be adding in the size, it's minuscule compared to the image that you're actually running. What you're getting is just so much more valuable than what you're paying for when you start using Dapper, because everything just becomes easy because just Dapper does that for you. So that's what I wanted to show you real quick. One other thing I'll tell you about this demo is that you can do this demo yourself. This is one of the samples inside of the Dapper repo. So if you go to the Dapper samples repo and look up the sentiment analysis for Twitter, you can see all the code downloaded and play with it. We have .NET version, Python version, Java version, and a Node.js version of this application. So whatever language that you're familiar with, you can actually download and start playing with this demo as well. So Brian, that's what I wanted to show you, is just how powerful Dapper is and how it lowers the bar of entry when it comes to developing microservices. I've been a developer for a really long time. When I started looking at Spring Boot and I started looking at Steel Toe and I started looking at all the different things that I had to learn to do microservices, I kept thinking, maybe I can live without them. And then all of a sudden I got introduced to Dapper. I'm like, oh, wow, this opens up this whole new architecture to me because it lowers the barrier of entry so well.
Nice, beautiful. Yeah, it's so nice to be able to just wrap your code, as I mentioned before, with something that handles a lot of the runtime for you. And you know, the great thing about it is you don't need to change your code, right? You're changing the wrapper itself to actually change the behavior.
Right. The component is the only part that you have to change. And
right.
I honestly I thought it was too good to be true when they were first kind of pitching Dapper to me. I'm like, yeah, let me try this for myself. It can't be that easy. And then I changed 2 files. And next thing I know, I'm running in Kubernetes in the cloud. And I didn't change a single line of my application. I thought, okay, this is revolutionary. This really changes the game, because we've all gotten the promise, write it once, run it anywhere. That promise very rarely holds up. But then all of a sudden I'm like, wow, this is the first time I've actually seen that work really well.
Yeah, that's great. I did post some pre-made tweets that we had to manage sentiment while you were
cool.
showing off the app. So the sentiment should be slightly different now.
Yeah, so if you go back to my screen here real quick, I can show you how that's actually been handled here. So here you can see Nitya did some really good negative tweets for us. We have one where she's obviously happy as well. And then we have an example of a neutral one as well. So what it does is it takes the text that it reads, and we're sending that over to AI and sentiment analysis, which is a nice component we have inside of Azure. And it basically tells us, was this a positive, negative, or neutral tweet? And then you can obviously aggregate this information and make some really well-designed decisions on how is your company doing? How is that new feature that you just asked about doing in the wild?
Great. Hey, I did want to mention this is a live broadcast, and if you want to ask any questions, aka.ms/learntv. Check in with us there, and please do ask your questions. We do have a couple from the audience that I wanted to share with you and see if we could get some info. Where would you find a list of all the possible state stores
Oh, good question. So let's bring Mark back with us too, because Mark's going to be able to answer a lot of these questions with me. But the first place that I would go is to just back to where he told you to go to. Go to Dapper.io, and under operations, it's going to show you the components that we can have. As a matter of fact, I believe I can get us there pretty quick.
Yeah, if you go to docs.dapper.io, and if you go to our docs, underneath our docs, there's a list of them. The actual components, in fact, the thing that we'd love to see you to do is that people can come in and build their own component. And you can build them for state stores, you can build them for pub sub, you can build them for secrets, you can build them for binding. That's a very common one people like to do. And there's a separate repo that you can build these things in. You can then sort of donate them into this repo. We hook them all up. And to write one is pretty straightforward. You just have to sort of conform to one of those interfaces of what you're building against. And so,
I wrote one of them too as another. It's a really good way to learn what Dapper really is, because on my screen right now, I actually have some of the generic state stores. And my favorite is obviously the MySQL state store. I think it's the best state store in there because I wrote that one, which is kind of cool. So it obviously has to be the best one in there. But it was a really cool experience to go in and see how quite easy it was to write another state store and be able to contribute to this, which is kind of cool to have your product in the box have your contribution, I should say, in the box of a product this cool is really exciting. But I found it very easy to write. You got to learn Go, which was the weirdest thing, and it only took me a couple hours to learn Go because that syntax is so weird. But once you get past the syntax, it's fine. It's just code at that point, and it's a really good way to learn Dapper.
Yeah, and a good way to learn Go.
And a good way to learn to Go for sure.
It's and so if anyone wanted to contribute their own state store, that's an option as well, I assume.
Oh, absolutely. Yeah. So there's a special components contrib repo that we have that has great documentation on how to walk you through setting up your development machine and then starting to contribute and even testing your component against Dapper. And there's so many great examples by the components that already exist. They're all well written to where you can get one that's probably pretty close. I use the Postgre as an example for me writing my SQL one, and it was very similar code. A couple of things obviously had to change from the syntax of how you pass in parameters, for example. But generally, the API was already implemented for me, and I would replace the SQL that was for Postgre with the SQL that's for MySQL, and it was quite easy for me to write a new component and add it. And the pull request experience was really positive, right? The team was really encouraging. They would help you make any corrections, make sure that your pull request was in a line so that they could merge it into the main branch as quickly as possible.
Yeah. And we're seeing quite a lot of contributions, not only in generic ones like that, but other clouds as well, which is kind of interesting. In fact, we're doing quite a bit of work with Alibaba, for example, at the moment. We're going to put a lot of Alibaba components coming up along there soon. So, the same way I could switch out that state store to be table store, I could also switch it out to other clouds and things like this. So, think about the potential and the power of that. We have a lot of our customers today talk us about that they need a multi-cloud experience.
Yep. Yes. Yeah, I get that request all the time. And Dapper is agnostic, right? There's nothing specific about it at all. So, and because when I wrote the MySQL, I wrote it against MySQL running in a container on my machine, and then I tested it to running in Azure, running in AWS, or running in GCP, because to make sure that MySQL worked no matter what. Because it wasn't about where it was running; it was about it's MySQL running, and I thought that was really nice too.
Yeah,
sweet, great. There is one more question that just came in. James was asking. He says, "I love that retry and back off logic is out of box, but what about scenarios where you want to override the logic? Can this be handled in YAML?"
Yeah, right now the retry logic actually isn't exposed for you to be able to change it right now. That's actually one of the requests that have been asked. The retry logic is an exponential back off, so it tries once, waits, and does exponentially backs off on that. So it's kind of built into there. There's actually an open ask on the community that we can actually make that configurable, and so we can do that. It's just one of the things we didn't get to. You actually sort of need retry in quite a few places. You think about the calls between your services. We also can do retry logic on state stores themselves and things like this. So yeah, right now it's not configurable, but it's actually built in. We just got to sort of expose that into the components itself, and then just say, well, here's the retry that you can set up inside your configuration files inside there. So I'd expect to see that coming pretty soon because it's pretty common request. Same with some of the other things as well in terms of like circuit breakers. People ask, can we have different types of circuit breakers to do things, which is another common pattern. So you can see that happening. Yes, not right now, coming soon.
But if you want it sooner, then you just send us a pull request.
Exactly.
Exactly.
Don't wait on us. Like I tell people all the time, don't wait on us. It's like you can send us a pull request. I sent pull requests before I was a member of the team. Again, the pull request experience has been fantastic on all the repos. So don't be intimidated or I know how scary it can be to do open source for the first time and understand what I'm allowed to push and not push and what's in my pull request. But their contribution README is really clear and the barrier of entry is very low. So I've been able to contribute to samples, to contrib, and to docs with very little friction.
Yeah, and in fact, that's a great point. In fact, and if we look at it, we published a sort of an initial just stab at a roadmap. We've spent we released Dapper 1.0, by the way, last month, which was a fabulous milestone. That means for the 1.0, it has the ability for you to run it in production. We have quite a few customers who are running in production today. You're going to see the customer stories on our blog, people like Zeiss, Ignition Group, Roadwork are some of those examples. You'll see many more of them coming soon as they actually finish up their sort of final production testing. And the good thing about that shows it's some maturity around all those things. And so we published a roadmap a little bit after this about what it looks towards. People said, what are you going to do next? I think sort of one of the most exciting things we're going to do next is that people ask for a building block, for example, around configuration. It's very important to set configuration on your microservice. When that starts up, we have things like Azure Configuration Service. Other cloud providers have configuration service as well. And often you want to have sort of configuration stored even inside like your local machine or your Kubernetes cluster. So those are sort of things we're looking at, to help you further build out these microservice architectures. So we see a lot of people, in fact, all those companies I mentioned, they said that reduced their development time by 50% from where they were. It'd taken them a lot of time to pull together their choice of frameworks. They had to bind in, they didn't know whether they were going to use RabbitMQ or Kafka or Event Hub. They were trying to decide. They said all of that was taken away from them. They stopped all the infighting in their teams. They said, it doesn't matter. We're using Dapper. We can decide the week before. And then, they were able to build their things much, much faster. So the speed of development really, really is where Dapper comes to its fore.
Sweet. The roadmap, is it on GitHub? Where can people find it?
If you go to GitHub, I can share my screen here. If you just go to GitHub, let me share my screen here a moment. Okay. If you go to GitHub, and you can see my screen here, okay?
Yep.
This is our repos. Actually, there's the repo for Dapper itself. This is the runtime. This is the components one we were talking about. So, if you go in here, and this is the state stores inside here. Here's all those different state stores. Where's my MySQL one? Yeah. Yeah. Here's the one with Donovan's name on. Oh, your picture's not here. If you go back and if you go to Dapper itself, you'll see that underneath Dapper here, underneath our issues folder, underneath here, we pinned it up the top here. We just put, this is our release planning and how we do it each milestone. And we just popped up here the 6-month plan. And we just kind of pulled some things together. Here's some things that we're going to do in sort of our active space, observability. Another one that we have a lot is people say, what? I have to put my own tracing in a lot of times, and I want to do my own tracing. Can you just give me a little observability API so I can, push some traces out, and whether I send it to Zipkin or Datadog or New Relic or App Insights, you do that for me. So, that's this one here. We've got some things around service invocation. So this is our little roadmap inside here. And feel free to comment on this or, put your favorite ones here, things like this. So this is just the 6-month plan. So everything kind of built inside the open inside here. And we often put an issue at the top here that you might want to vote on that we think is interesting. This was one about, supporting concurrency and how we do it inside our database store, optimistic concurrency versus and some of the improvements around there. So you can read some of these issues. But yeah, go in here, feel to dig around and post your own side of things. I would also say that, Discord is a great place to go and ask questions. If you want to figure out, what to do next, we have a Discord channel. And if I just pull this thing across in a moment. I'm just starting Discord. I realized I'd shut it down. If you pull Discord up, we have a Dapper channel inside there you can join, and that allows you to ask lots of great questions. So please go to our Discord channel inside here. You see here is Dapper. You can ask questions. It's just ask us some general questions. Our general runtime here. So please come and ask questions here. Very vibrant community. We have actually nearly 1,000 people now in our Discord channel who are very, very active. So yeah, it's kind of, this is a great place where you want to jump in for questions.
Okay, great. Thanks for that. That's a great overview. It's good to know where people can find things. It's not always obvious, so it's great to take them straight in. One last question, SDK support. What SDKs do we support? And where can they find more info about that?
Yeah, let me share again. It's always best to just show you how to find these things. If you go into our docs, if you go to docs.dapper.io, these are a great doc inside here. It shows the language SDKs down here at the moment. So you've got .NET, Python, Java, Go, and PHP are the ones that are in V1 support. Yes, you can actually go underneath developing applications. It's got the SDKs here. It shows a list of their some of their capabilities. And if you go to each one of these, if I click on the .NET one, for example, it takes me to a .NET view where it dives in further with more examples around how I build. So with the client that I showed you earlier, here's some examples about getting going. And so yeah, feel free to try these out. We've got the PHP, Python. We haven't put all of the other ones in here just yet, but they've each got their own samples. So if you then go off into the actual repo itself, so you can actually go down into the repo. So for example, down here is the .NET SDK, and there's a lot of examples inside here that you can sort of try out as well. So those are the SDKs that we support today. And these are samples that are sort of .NET specific around them all, and try these all out. So that's the way you can sort of navigate through all of those and try out the different SDKs that we have available.
Wonderful. Okay, well, great. Thanks. This is the part of the show where we usually do a recap. Today we have something special. Nitya Narasimhan is going to come back, and she's going to show this amazing sketch note. Nitya does these amazing sketch notes for other things. It's a real combination of art and science. She has a deep, a good knowledge of the applications, of the background, and the technology behind them. And then she uses her artistic skills to add this amazing visualization to it as well. So I love watching these. And yeah, Nitya, if you want to share your sketch note.
Thank you. We actually have two things to share, and I'll try to make it quick. First of all, I think the thing I have to say is, someone said, right, when you want to have something solved, give it to the laziest person. I sketch note because it's the best way to learn. So this is the sketch note. You can find it on the Dapper blog. There's a visual guide to Dapper. But if you want to get like a full kind of summary of everything that you heard about today, this is a great way. Let me start from the beginning. This is a visual summary of the entire overview page on Dapper. So if I actually were to kind of bring it out a bit, this is the full summary. And we're going to go quickly and just see a couple of the things. Someone asked, what are the SDKs that are available? Well, now you know. What are the big benefits of Dapper? If you look at this, you immediately kind of get the big sense, right? It's a microservices support architecture that has building blocks. So you've got componentized things that you can compose, use what you need when you need it. You don't need to use everything. Sidecar architecture, so you don't need to integrate Dapper code into your runtime. It can run in its own container process. You connect to it over APIs. It can be HTTP or gRPC. If you do want to have like a higher fidelity experience, there are framework-specific SDKs, language-specific SDKs. You can go to that link that we kind of shared a bit earlier. And these are some of the frameworks and languages for which SDKs exist right now. But the most important takeaway for me is that there are three things that make Dapper really cool. One, it is portable, so you can come in there and you can kind of move to whatever language you want. It is it is portable also because you can start from localhost and move into the cloud. You can go to Kubernetes. All of this, and this, I'm watching these demos going, holy, right? Because you didn't have to change your code. You could do this with configuration, which is very cool. Last but not least, there is a whole bunch of community-generated packages. There's a Discord server. There's a really vibrant community where you can go in, and if you don't have the component you need, if you don't have the feature you need, you can get them to support it. But I want to kind of zoom out and just walk through some of the different things that you can go find on the overview page that are visualized here. And the link that is in here will give you a link to a high-res version of this that you can watch on a 4K TV and look at it in your own time. So what are the things you want to know? Sidecar architecture. Dapper and the app run in separate containers or processes. You have Dapper codifies your best practices for building blocks. So you can componentize and compose your applications. Here's a whole bunch of the core services that you can take advantage of simply by connecting to Dapper over an API. So you can kind of outsource some of the kind of underpinnings of getting your distributed application running and focus instead on making your application logic perfect, right? And I'm not going to go through this because I want to actually show you my kind of like review of what we did today, but I will leave you with this. This is the Dapper 1.0 is here announcement. The 3 things you need to take away: it's production ready, it is open source, and there's a huge ecosystem around it. But if you can switch over to the video, this is going to be a 30-second moment of zen. And I don't know if you can play it. I was trying to kind of like sketch note this as they talked. And Mark and Donovan talk a lot. So at the end of this, I will clean this up and put it out there. I've also tweeted this. But what it is it's kind of like a summary of everything you learned today. Some of the things that are highlighted in white are the ones that you want to kind of take away. It's vendor neutral. Dapper Run will wrap your application and run it for you without you having to do a single line of change of code. The Twitter sentiment demo that Donovan showed kind of walked you through a workflow where you can work with multiple services. There were 3 services. You connect to all of them, run an end-to-end demo. We looked at observability. We looked at how we can actually take advantage of moving something from a local hosted, tested version to the cloud, and so on. So that was my speed review of everything. I really, really hope that you will go and check out the visual guide. It's on the Dapper blog, so dapper.io/blog. And if you check out the Twitter post right now, just look for the hashtag Dapper does that. I actually love that because it tells you everything you need to know. You don't have to do a lot of the underpinning. Dapper does that for you. So just check that out and you'll find the video, and I'll try to put a nice cleaner sketch note later. Thank you so much for having me.
That was great. That was great. Yeah, if we don't get everyone back on, that's great. We've got a few more minutes actually. During this time, actually, I just want to share my screen as well. I've got an overview here where for those folks who are watching the recording of this, or if you want to get more information, we do have all the links we've shared here, and we will add more. But if you go to aka.ms/the launch space Dapper1, you can find all the information that we shared here, including the links and the app in the show today. So we have 3 more minutes, and one thing I wanted to talk about, Donovan, you had mentioned over the weekend, I saw you on Twitter talking about integrating Docker Compose and Docker locally with Dapper in a container, and I was actually surfing Stack Overflow. And there's a lot of questions about how to do that. So I was wondering if you want to give a quick overview of what you did over the weekend to make that work, and maybe just give some pointers to folks who.
A lot of that credit goes to Jeff Holland. Actually, yeah. I was like chicken and egg, right? I'm in an image, but I need to be able to do a Docker PS outside of that to the host machine, because that's where I actually need to see where the images are, and I want to be able to run kube commands against the host machine of the image that I'm in, right? So it's like, how do I get outside to go do that stuff? And I was lost, so I just went to Twitter and said, hey, this is what I'm trying to do. Does anyone know how to do this? And then Jeff, like within 5 minutes, said, yeah, I do this all the time. All you need to do is map your docker.socket to docker.socket, and your Docker commands will work. I'm like, oh, really? Like, cool. So my next challenge was, then how do I get Helm to work? Well, then all you have to do, same exact technique. You basically map in your kube config into your image, into the exact place your image expects kube config to be. And as soon as you type kubectl commands, they are actually hitting your Docker for desktop, even though you're inside of an image. So now I can run Dapper init, I can do Dapper run, I can literally develop inside. And that was my goal. My goal wasn't to test out Dapper in a container. My goal was to develop a component inside of inside of Docker, right? Because my next goal was to be able to I want to create a mock component, because the Twitter demo is great, but I'm relying on people to tweet the right kind of thing. What if I want to be able to mock out that component? And I want you to pretend to be a Twitter binding, and I want you to send tweets every 30 seconds. that way my demos are always going to be perfect. I know exactly what tweets I'm going to get. I don't have to worry about profanity. I know exactly what sentiment I'm going to get. So what I wanted to do is like, how can I develop that very quickly? Well, I want to develop it inside of a Docker image that has all the code, has everything configured, and I'm going to create a mock component at some point when I have time.
Mock components, awesome. Well, I just wanted to wrap up. Thanks, Donovan. Thanks, Nitya. Thanks, Mark. Great show. For anybody who needs more information, aka.ms/the_Dapper1. Thanks to everyone who joined us today, and we'll see you in the next show.
Thanks for having me. See you.
Yeah, thanks for having me.